Thanks a lot for the nice words, and excited to be in front of you here. And yeah, my name is Michael. I'm part of Schneider Electric, and personally I'm leading the business of our industrial automation and our software-centric automation approach in the DACH zone. So for Germany, Austria, and Switzerland. And with our universal automation approach, we probably got our most innovative and disruptive approach since many years. And let me start maybe with who we are as Schneider Electric and what our mission is. So I'm personally quite proud to be part of this company since 8 years now, because we are a really committed and purpose-driven company. So by saying that, our major mission, or what we say, who we are leading digital transformation on two parts, on energy management and on industrial automation. And what we can also say, and we are quite proud of this, we can say that we are the most sustainable company of the world. So what makes us so sustainable, and what's the link towards digitalization? So there are probably two major reasons. If you look at Schneider Electric, you would find several, but two major reasons what makes us so sustainable. First one is that we lead our ecosystem by example, meaning that I think in 2005 we've been one of the first companies adopting the ESG, and since 2005 we've been reducing our carbon footprint year by year. We've been 10 times in a row being ranked with an A on the CDP, and we are implementing not only strategy but efficiency levers and also the digital tools to optimize all our operations in our own company. And if you look on the future and the commitments of Schneider Electric, you will see that by 2025 all our operations will be carbon neutral, and in 2050, which is even a bigger challenge, all our supply chain will be at net zero. And the ones of you who might have cared about how does a carbon footprint look like, you probably realized that 90% of carbon footprint is not inside of your own operations. And if you now imagine that you bring your carbon footprint to zero, this means you need to reduce your full ecosystem from your suppliers until the full life cycle of your product if you want to become carbon neutral. And the second reason is that we exactly do this for our customers. So, and I can tell you there's a large appetite currently in the market asking us to develop strategies how to become climate neutral, and then asking us to bringing those strategies into actions, on the one hand with efficiency levels, where we implement efficiency, and on the second part, where clients need digital tools, need connectivity to track and trace the carbon footprint downstream in the own operation, but also upstream. And that's where we believe that we are the best digital partner for sustainability and efficiency. Nevertheless, we still see a lot of digital challenges in industries when we come into our customers, and I just want to use one example where we are quite profound in the business. So the CPG industry, especially the food and beverage as an example. And we see, let's take the food and beverage as an example. We know that the industry has progressed a lot. There's a lot of connectivity. Production gets more and more modular, but nevertheless, there's a tremendous seek for open standards. We see a lot of organization being founded for standardization or more openness of systems, because we see that there are massive boundaries in terms of automation and connectivity preventing our clients to reach the full opportunities. And I want to highlight three major examples of digital challenges of one of our CPG industry client. And the first one probably is how is business resilience. So we all know that industry is not only highly competitive, especially F&B, it's also rapidly changing. So from one day to the other, you are forced to change your batch size. You've got a fluctuating demand from the market, and you've got a really high diversity of products to face with. So our clients need to be more and more flexible and need to reduce time to market tremendously. And now we ask ourselves, so nevertheless, we still stick in automation and proprietary systems where our clients are not able to be really flexible. I want to give you one example. I think COVID has shown us that especially shortage issues. So you've got suppliers who are not able to deliver parts to, and end customers are forced to go to other vendors to use multi-supplier strategies. They simply cannot do this in automation today because we've got a clear vendor log in automation, and this is a real issue if we look into resilience, which we want to unlock, and where we think that interoperability in the automation world is a real need today. And we just see this right now in the COVID situation. A second point is engineering agility. And you see this picture here? I will use this slide here. So you see different parts, and you already can recognize that it's quite modular. So you've got some starting line, some filling, some first packaging, transportation, second packaging, end of line here. And now imagine that you need to switch some part from here to here, or you need to change some modules inside of this factory to react on batch size changes, new product options. So wouldn't it be really beneficial if you could make those changes on a software-centric base, independent of the underlying automation hardware being implemented in this whole factory? So we think that a cross-vendor interoperability and the real portability of the application of automation being implemented here is a need to be really agile in today's industry. And the third point is traceability. So we see that sustainability is only one part, but health, regionality, there are a lot more reasons than cost that the clients of our clients buy the products. So we need to ensure that we bring this data from this factory. Just take the carbon footprint as an example, even outside of the factory, from the suppliers to the operations, to the customers, and track all the data, bring this to the analytics level. So this is full traceability of a carbon footprint. On the other hand, we need on an automation level to look on the regulations like hygiene and to ensure that the quality of the production is always on time. So we think it would be perfect if we would have a seamless integration of this OT world into the IT world, and to bring the data in a consistent way and run the services just like analytics for traceability on top of all the automation data, independent of which kind of vendor and technology is implemented. And we question ourselves, what do we need? Which kind of paradigm change do we need to enable to overcome those challenges? And if we look back in the history, the latest really big paradigm shift was in 1968. You see this gently smiling man. It's Mr. Dick Morley, and he was facing similar situations. So customer requirements on the one hand and technical limitations on the other hand, such like limitations of calculation capacity of processor at this time, or the bandwidth of communication. And this led to the point that he started executing runs in a cyclic loop, and he invented at 1968 what we call today the PLC, the modular digital control. And this technology has evolved a lot in the latest year, but it's still the major core of how we try to solve those issues here, and we also try to connect with technologies like digital twins, machine learning. And we at Schneider, we asked ourselves, do we think that this is really the technology where we can make the next quantum leap and where we can bring the benefits to our clients to face the next challenges? And we think we need to make a bold move now, and we need to leave our today's paradigm to a certain extent and to create something which is more software-centric, which is portable, interoperable, and we said that we need universal automation. So what's universal automation? I think you've heard this word App Store several times. I heard this from one of your participants yesterday during a talk. So you can imagine it like an industrial automation app store. And it's at the end the world of plug and produce automation software components based on an IEC 61499 standard to solve specific customer challenges. And the idea is to use the same paradigm like the IT is using since many, many years, to embrace open platform, and we think that we need open platform in automation now as well. So that's why we today are calling many of our vendors to adapt this 61499 standard, and we try to generate a cross-common vendor approach in our industry. And we really believe at Schneider that a lot of vendors will adapt this approach and that end users will demand it. And that's why we also launched the world's first universal automation offer. This is what we call EcoStruxure Automation Expert. So EcoStruxure Automation Expert is the world's first software-centric industrial automation system. And what's different, considering the points we've just spoken about, to how we do automation today? So the first one is we bring the full mindset of IT world into automation. We do things event-driven instead of cyclic. We want to create a flexible engineering, and we want to be able to deploy code and automation application to multiple platforms. Being ready to talk directly from PLC into the IT world, being it MES or ERP. And the biggest change is we want to get a full platform independency by decoupling hardware and software. I will come to this just in a minute, but I want to highlight 3 examples of benefits you can expect from this. So the first one is with Automation Expert and our universal automation approach, we want to drive engineering efficiency. What do we mean by that? So at the end, we want to eliminate as much low-value engineering as possible. One of the biggest bottlenecks in automation projects is usually if you want to make in a heterogeneous system, make one PLC, one control talk to the other. And this, for example, is something where we believe that this must be solved 100% automatically by a software system without mapping any PLC to each other and making them talk. A second point is that we want to be operational effective. This is where we imagine to use a much more asset-centric approach as we've got today. We know this from the digital twin world as a cyber physical asset, probably, that we stop commissioning PLC and automation and logic functions, and instead of this creating physical objects in our automation world and putting as much, encapsulating as much know-how as possible and much more than logic today. And the third one is to be future-proof. And just imagine the control where your automation is running today gets obsolete in a few years, and this is a quite common case for a lot of clients. So I think, and we think at Schneider, that it needs a paradigm shift, that you can take your code from a PLC and can put it on any platform you would like and can run your application just as you want. So coming back to this decoupling of hardware and software, which is probably the biggest change in this approach. It's how do we automate today? Today, we've got specification on some hardware. So we choose a hardware from any vendor, and we already know that there's a dedicated software to this hardware. And we look into this software and we see that there's a dedicated library to the software. And we start to see how can we solve our application with this hardware, with this software. This is a pure vendor lock, because if you want to change from Schneider to someone else, from someone else to Schneider, you could take every example from the market. You will see that it's not easy to migrate any application to another platform. And even inside, if you change just some firmware sometime, if you upgrade some hardware, you will see then even then you are sometimes forced to use a next generation of software. So the life cycles of hardware and software are completely dependent from each other. And this is where we think we need to unlock. And the way, and the 61499 is the standard, which was developed on the standard we use today in automation by the same people, where we start completely on a different way. We start to automate application first. So we solve what needs to be solved in the software world. And then we are able to distribute this application on distributed architectures, on central architectures, on PC-based architectures, on control-based architectures, on any platform you would like to have. Because we've got the symlink layer in between, and there's no dependency any longer between this piece here, which is not any longer some logic piece. It's a physical asset. In this case, it's the conveyor system you've seen on the transportation part inside the CPG example. Those are different belts here from the conveyors. It's a physical asset, and you can tell the system where it should run on which kind of physical asset. So that's a real paradigm shift. And if you think this further, you can imagine, and it's not only the cross-vendor advantage you've got, it's also the advantage that you can run in the future automation on any kind of device where you would like to have it. So you can run automation on logic control, on industrial PC, but also you can generate connected products. So why don't you've got some frequency drives inside your operation. So why don't you run application and code directly on a frequency drive or directly on an intelligent I/O system? So the IC 61499 standard really enables you to put code in a portable way on any kind of platform you would like to have. A second point which I would like to highlight is that we think it's necessary to change automation to get it more event-driven. And by saying that, I see three major points. So the first one is today, automation is working in a cyclic way. And if we look into the real world, there are not a lot of things happening always in a cyclic way. Most of things are happening triggered by an event, and something is happening. And that's how the IT world is working since many, many years, but not the automation world. So we believe that by doing automation in an event-driven way, we do things much more efficient, but also, and you can look on the picture here, we need to think, how can we attract the automation resources of the future? Because I've got some numbers in mind. In the surrounding of Boston, of the big town Boston, you've got as many IT guys as automation engineers on the whole world. So we need to consider, and this is the feedback we receive from our clients as well, we need to consider how can we make automation easier or more usable for new resources, and we need to simplify in the event-driven way. So this is, for example, an example of highest level of code. You've got physical objects, where we will come to this in a minute. A lot of know-how is already encapsulated. And you've got really simply engineering. You've got events and data being exchanged between those assets. And everyone can imagine such an asset. A process guy, IT guy, automation guy. And if we find such a way of simplified automation, we can imagine that we in the future can attract more and more resources also for the automation world. And the third point is that this way of automation is much closer to the IT world, so we can get into the seamless integration between IT and OT. And this is an example here that just imagine you let your code run on an IPC, so on a computer, and on the same computer where you've got your control running, you've got the analytics like machine learning, like the dashboards for the traceability just as mentioned, and you've got the direct connection on the same device between the automation and the IT world. And imagine the full scalability from a Raspberry Pi until to an edge computer with multiple instances. You've got a lot of potential here, and the event-driven mechanism and this IT closed system is one of the real advantages to bring automation and the IT world much closer in the future. And the third point is this asset-centric automation I mentioned. And if we remember back on the picture of this factory, where we said we would like to change an asset or some application inside the asset. And we think back that we want to make things easier for engineers to work with. This is exactly what we want to drive. We want to create plug and produce modules where we've got the automation from today inside, the logic, but only as one part. But at the same time, if you want to make a change, you've got already encapsulated in your control block, in the physical asset, the visualization, the connection to the real world, the documentation. So we try to encapsulate in such a what we call carte inside a physical asset as much as possible in order to work on an automation level. And here we can also make the link to as well to the digital twin. We change our automation just as required. We put some additional line inside. We copy and paste in physical asset a carte, and we can also directly simulate what we see on the software layer, and we do not need to care on the underlying hardware. And just as a latest step, you decide, I want to run this new application, this applicated application. I want to run it on this hardware, on this platform, and this gives us full flexibility in the future to change automation. And as a final statement, I just want to emphasize that we also will contribute on other parts into digital twins. So we've got Matthias, who you might have met. He's one of the chairmen of the Industrial Digital Twin Association. And you can also see here that Schneider has a clear vision. If you look on the words, we say, yes, innovation, but standardization and open standards. And we believe that universal automation, openness, interoperability is now really the next step we need in automation. And this will be a key driver for a lot of technologies and also for digital twin. And happy to connect with you in the roundtable. And thanks a lot for your attention. And yeah, speak soon.